as you can imagine, quartic polynomials will have maximum 4 degrees. So the standard form will look like a x to the power of 4 plus bx cubed plus cx squared plus dx plus e. So you have maximum 5 different terms, and then maximum of your degree, highest degree is 4, right? It's not always going to look like this. So to be able to sketch your graph, you're going to have a lot of different vector forms. So as you can imagine, you have maximum 4 different zeros. So you have alpha, beta, gamma, and mu. Let's put it this way. So you have this kind of form. That is the starting point. So second one, you have 1 reduced. You have altogether 3 different vectors. So 1 is repeated. And then the third type will be a cube vector. So repeat it 3 times and then 1 linear. So you have altogether 2 different zeros. The next one is going to be 1, 0 repeated 4 times. So we're going to go through it one by one later. So number 5 type is going to be 1 quadratic vectors and then 2 linear vectors. The last one is going to be 2 real quadratics so those discriminants for both quadratic equations is going to be less than 0. So you don't have real solutions. So you are going to have 4 different complex numbers zeros. So don't worry about it if you don't take it all in. In the previous the slide is fine. So we're going to go through one by one. All right. So the very first type, 4 distinctive real zeros. So as I have mentioned briefly, that you are going to have a form, general form, like something multiplied in front of those linear vectors. You have altogether 4 linear vectors with 4 zeros. So x minus alpha, x minus beta, x minus gamma, and then mu is your last 0. So I'll just plug in something that makes it easier for me to graph. Let me use it 1, 3, and -1 and -3. So 1 and 3 is your zeros, and -1 and -3, for instance. And then your a is 1. So a is 1, which is greater than 0. So guys, now let me ask a question. If you have a, which is 1, which is greater than 0, what do you think will happen with the graph in general? Well, let me remind you of parent function of your quartic equation. Y equals x to the power of 4. The quartic equation looks kind of like this, right? It looks similar to your quadratic equation, x squared, but x squared goes slower, so it's more wide. While your quartic equation goes faster because it multiplies so much faster, right? So this is when the case when a is 1. Like, let me ask you the question, what happens if your a is -1, thus it's less than 0? What do you think it will happen? Annie, what do you think? When a is less than 0, which is -1, what do you think it will happen to the graph?
It will become like below the x-axis.
Very good.
Negative.
Very good. So when you have -x fourth power, then everything should stay below x-axis, which means you're going to flip it. You select it like that, right? So maybe that was a little bit too wide. You know what I mean? Yeah.
Yes.
So what we're going to have, because I decided a is 1 for this specific case, I am going to have something that opens up, right? It will opens up. It's going to look something like this. But in the middle, you can have like some kind of like, I don't know what's going to happen. There's going to be like locally up and down in the middle. But generally, when you drag your x to positive infinity or negative infinity, to those directions, your y is going to generally go up and up and up towards the infinity. Okay? So if you don't know what's going on in the middle, what kind of drama is going to go, we are going to actually plug in specific numbers to check it out. Well, the best thing you can do is just plug those polynomial into your graph calculator. But let's just try without it, just to have a better understanding. So let me start with the easiest one. Using the factor theorem, if you plug in 1 is x, then you have 0, right? 1 minus 1 is 0. Everything is just cancelled and 0. 3 is also gonna make it 0. Negative 1 is also 0. Negative 3 is 0. Okay, that's clear. What are other significant numbers that I can plug in? Let's see, I have 1, 2, 3. So these points I'm gonna hit a 0, and then negative 1, negative 2, negative 3. These numbers I'm gonna hit 0. What's gonna happen between negative 1 and 1? So 0. If you plug in 0, it seems like 0 minus 1 times 0 minus 3, 0 plus 1, 0 plus 3, so it's going to look like 9. So when you have 0, you have 9. You go through this point. So I'm pretty sure it hits down from 9 downwards. Okay, but you have to go down and then you have to go up again because you have to touch this 3 and negative 3. So let's figure it out what happens when you plug 2 and negative 2 in for x. So when you plug negative 2 minus 1 is negative 3, negative 5 times negative 1 and 1, it makes it 15. Sorry, yeah, negative 15. So you're gonna hit something like negative 15 or negative 2. So it's gonna hit here and then go up and forever and ever. Because this is kind of symmetry, I don't even need to calculate it. You are going to go through the same coordinate, 2 and negative 15 and negative 2 and negative 15. So it goes up again like that. So you are going to have generally opening up the curve that opens up, but locally in the center, it's gonna have like up and down, like local maximum and local minimums. Okay, are you okay, guys? Can I move on?
Yeah.
Okay, very good. All right, so number 1 type is 4 distinctive real zeros. We already covered this question. So what happens when a is 0 greater than 0? Then you have the curve that opens up. When a is less than 0, then it's gonna opens downwards. Okay, concave up, and this part is going to be concave down. Okay, how many x-intercepts did you have in type 1? How many? So you had 1, 3, negative 1, and negative 3. How many did you have? Any, you continue. How many?
4.
Exactly. 1, 2, 3, 4. So you have 4 intercepts. How many turning points do you see?
0.
Turning?
Oh no. 1, 2, 3.
Very good. 3. All right. So can I move on? Do you guys have more questions on the first type?
No.
No. Okay, very good. So now you have to think about different cases. When you have 2 real zeros, what does that mean? So you are going to have 1 0 repeated. So I am going to make sure that I have x minus alpha square. Okay, don't forget about some kind of leading coefficient a. And then you have 2 distinct zeros. So you have to have multiple of 2 linear. Okay, so maximum 3 zeros. Let's take an example. I'm gonna now make it more interesting to make it negative 1 for a. And then the first 0 is going to be 2. And the second 0 is going to be 0. Third 0 is going to be negative 2. So it's easier for me to sketch the graph. So it's very clear that if I plug in 2, I have 0 because of the vector theorem. We decided that 0 is our second 0, and the negative 2 is our third 0. Right, that's clear. So according to this vector theorem, I have something looking like when I have 0, when I have 2, when I have x is negative 2. You hit zeros. But I'm not sure which part will go up and down. But one thing I'm clear is that a is negative 1, so less than 0. So it's going to have a generally downward, concave down. So I know that it's going to go down from here, but I'm not sure what's going to happen specifically from here. So, well, let's hit p negative 1 to figure out what's going to happen in between 0, x is 0, and x is negative 2. So I have minus 1 multiplied by negative 3 squared times negative 1 times 1. So I have negative 9 times negative 1. So I have 9. When you have negative 1, I am going to have 9. So you have all the way up there. And then you have to come down because of 0 and 0. And then you only have to figure out when x is 1. That's going to look like negative 1 squared times 1 times 2, which is negative 2. So I'm going to come down right here and then go up again and come down. Right. So what's going on at negative 2 and 0? Hold on. Hello, Boram. Unmute yourself. Yeah, so how many intercepts do you see here?
1, 2, 3.
3. So altogether 3 zeros, right? But look at this point right here. Does the graph cut through x-axis?
No.
No. It barely just touches at one point, right? So what you have to remember in this type 2 is that when you have a repeated 0, the graph will only touch at that point, x is 2. And in other cases, it will cut through, right? So, so same with this. I don't want to repeat. Concave up and down. Let's skip the first question. Number 2, how many x-intercepts in type 2? You just answered as 3. How many turning points do you have?
3.
Very good. 3. Right. So what you're going to remember here is a square factor. The graph touches x-axis at alpha at 0. Okay, it doesn't cut through. Very good.